2.5. So for this part of the 2.5, so that method I showed you, the difference quotient, is the algebraic way of doing this using a little bit more formula base, right? So we have the preceding, following, centered interval, and now it's called the difference quotient method. So if we ask you for a specific method, we want a specific method, right? So here, this is going to go through a little bit of theory, and we're going to try to put it together a bit. So this part here. So this theory says the instantaneous rate of change. So this, whenever I say instantaneous rate of change, I'm saying tangent line, right? Instantaneous rate of change means the tangent line is 0, right? So the tangent line is 0 at a max or a min point, okay? At a max or min point. As a result, the tangent lines drawn at these points will be horizontal lines. So take a look what this is saying. If I have a tangent, okay, if I have a tangent line, and I'm drawing it at a max point or a minimum point, in order to draw this tangent, it would be, oops, I totally missed that. It would be horizontal. Like that. Okay, that's the first box. The second box says if the instantaneous rate of change is negative before the value, instantaneous rate of change again means tangent line, right? So tangent line is negative. So if the tangent line is negative before the value where the rate of change is 0, and then positive after the value. So we already have the rate of change is 0. So that's from the above, right? So the rate of change is 0. So that's part here, it's 0. So we got this part here. 0 means it's a max min. So first we establish if it's a 0. So that's step 1, right? So step 1 is 0. So we'll say step 1. Step 1. Once we establish that it is a 0, okay, so once we establish it's a 0, then step 2 is to check this. Okay, then we're going to check some points. This will be step 2. So step 1, establish that it's a 0. If it's a 0 and I check it, so I go, okay, I found the 0 here. So I got this part. So step 1 is I got the 0. Okay. If I check a value before it, so before, preceding it, and I put it in to check the slope, right? The slope, the rate of change, which is the slope, is negative before. So we're going to put negative before. Right, negative before, and then positive after, and I'll put the blue here, so positive after. Okay, so one more time. Step 1, you check to see if the slope is 0. If the slope is 0, you want to go, hey, is that giving me max or min? I know it's one of them. If the slope is 0, it has to be a max or min. Step 2 says if it is a 0 there, and I check before and I see the slope is negative, and I check after and I see that the slope is positive, where the rate of change 0 is positive, then a minimum occurs. Okay? So it's a negative slope, then a positive slope. Does that make sense? So negative, 0, positive means minimum. So this point here, I'll use, what color can I use? Here, this point here means it must be a minimum. Okay, so that's telling me that it must be a minimum. So that's this. Down, horizontal, up means minimum. Okay? Next, if the instantaneous rate of change, so same wording, is positive before, so So when I look before it, so it goes from positive before, 0, right? We've still got the 0 in the middle, and then negative after. So see how it changes? So negative after. So what we're saying is, first you get the 0, okay? Before it was heading up, the slope is up, right? After it, it's negative. So this is negative, and this side here is positive. And logically then, if it goes up slope, horizontal slope, down slope, this point here must be a max. Does that make sense? So up, max, negative. Up, max, down. So that's our check that we're going to do. So first we're going to use the difference quotient to find out what the slope is. If the slope is 0, so step 1, if it's 0, then we're going to use the second part to decide whether or not it's a maximum or minimum. So the first step we're going to do is do the difference quotient if it's 0. If it's not 0, it's not a max or a min. Already done. It's neither a max nor a min. If it does happen to be 0, right, so if we check it and we go, oh, wow, cool. I checked it and my slope is 0, then you can go on to step 2 and go, okay, but I want to see whether or not it's a max or a minimum. Okay, so here, we're going to use the difference quotient to determine if the slope is 0. So step 1, it's telling you what to do. If it's 0, then determine if it's a max or min. So it's literally telling you the 2 steps they want. So let's use the difference quotient first. Let's establish that it is a 0, and then we're going to check to see if it's a max or min. Okay, now let's check this. And is it always be a max or min? We shall see, right? We shall see. So difference quotient first. The point is x is -2, so that means a is -2. You don't have to write that, but that's what you're thinking. Okay, and we're going to do our formula. So again, let's go here on the left side. I don't know how long this question will take, but let's go here on the left side. So m equals, and this is going to be f at -2 plus h minus f at -2 all over h. Okay, let's plug her in to this beautiful formula here, and we've got -2 plus h squared, 4 times -2 plus h minus 21. That's the first one. Do you want to do this part on the side? Right, you can even do that in your head. So it's 4 minus 8, so -4, -25. Right, so I know you can do mental math or you can do it on the side. So if you want to, you can go minus and then just put the -25. Right, so if you want to calculate that part here on the side, you can. It saves you a little bit of writing. Okay, and if not, you can show it. So this part here, I'm just going to show that, is f at -2, which is -2 squared, 4 times -2 minus 21. Okay, and again, you don't have to show me that. If I just see the -25, I'm good with that. I'll zoom in a bit just so you can see my calculation. Right, so you can do that and just plug it in. And that's all over h. Okay, and then here we've got our expanding. So again, your choice. If you don't want to expand it, you don't have to. You can just use it as is. Maybe we'll expand it just because it's not that bad to expand. Right? I had some people making mistakes with their expanding. So you don't want to make any grade 10 mistakes here. When you expand this binomial, you're going to get 4 minus 4h plus h squared minus 8. Stop me if I'm wrong, please. 4h, and this will be -21 plus 25, so plus 4. And that'll be h squared. Those cancel out. Am I wrong here? You get 4, -4h, h squared, -4h plus 4h minus 21. So we get the 4h's are gone. H squared. Just an h squared?
Yeah.
Oh, look at that. Okay. Then what can you do here?
Can
you simplify further? Yeah, it's just h. So yes, that's okay. It usually freaks everyone out. They're like, wait, it's all gone. That's okay. So just simplify as far as you can algebraically. If you didn't, you could have left it in the form above with the brackets and subbed in there. You'll get the same answer. So what happens is that's my simplified formula, right? Sometimes it simplifies nicely, sometimes it doesn't. Don't be scared if it does. That's okay. We did as far as we could. And we're going to now substitute in the H1 and H2. Okay, so H1 and H2, we're going to say let H1 equal negative 0.01. Okay, and let, am I okay? H2, it's okay? Okay. H2 equal 0.01, like that. Is that all right? Stop me if I'm wrong. Okay, so we plug those guys in, and then we just have M1 is, oh, look at that. And you just plug it in, and there's really only one place to plug it in, so this will be negative 0.01. That's okay. And then M2 is going to be 0.01. When you add them, divide by 2, okay, so you can say, therefore, M1 plus M2 divided by 2 is going to be negative 0.01 plus 0.01 over 2, which gets me 0. So yes, we want to establish if it's 0, right? Determine if it's a max or a min. You already have everything you need to determine if it's a max or a minimum. You have all the information already calculated. So at this point, you want to just write a conclusion. What is the slope before the 0? You have it there. It's your preceding interval. It's H1. What's your slope? Negative. Okay? What is your slope after 0? You have that. That's the following interval. Preceding, following. You already have it all calculated. So you're thinking, oh my gosh, how many more steps do I have to do? One more. You have to do a conclusion. You have to say before was negative, after is positive, therefore if it goes negative, positive, it's a minimum. There you go. Okay, so let's do a conclusion. So we're going to say since, so you can use the symbol since M1 is less than 0, right, negative, comma, M2 is greater than 0, so it goes negative to positive, therefore it's a minimum. You can use more words if you want. I hate words. Just kidding. I like words. Words are glorious and wonderful. I do like words. I like reading all that sort of stuff, but just I hate writing words. Personally, I don't want to have to write anymore. I'm fine with this. You told me slope 1, which you told me where it is, right? So when you write the titles and you're explaining along the way, you told me the H1 is preceding by telling me H is negative 0.01. So you already told me that's preceding, which is less than 0. You're telling me H2, which you told me up here. So that's why. If you have steady steps here, you can follow, and this is good enough for me, 0.01, that's the following, and then so preceding, following, it goes down to up, so therefore it's a minimum. So in your head, you're thinking, oh yeah, so if it's down slope, up slope, it's got to be a minimum between it. Okay, so that's enough words for me. If it was an assignment or something in university, I would usually use a couple more words beside it, since this is the preceding interval, following interval, that sort of stuff. You could embellish with more words. For me, perfect. You told me before, you told me it's after, you established by the subscript which was which. Good, gorgeous, that's all of my information. Okay, we try it again next page. Any questions?